not going to take off the full 16 millimeters just yet. I'm going to leave myself a little bit of material to take off on the face so that we come up with a fairly decent cut on the end. So take off another 2 millimeters, and that's how it's going to go until we get down to final diameter. There we got our step all dug in here. I went down just about to the washer. I could cut into it, but I want to leave enough material there to maintain pressure on the arbor. So now I've gone to the 16 millimeters on the travel dial, and now I'm going to go ahead and run the tool in on the cross slide here. I left myself a little bit of material here so that way that get a nice finish. We'll take it down to the center here. We're going to leave this on for the duration of the project until we get the gear almost done. Now, there's going to be about 1/10 of a millimeter material left on here. We're going to go ahead and leave that just for shits and giggles, mainly to compensate for any errors that might creep up later. Okay, there we go. Now the nice thing is I can cut into the center hub as much as I want to. It's not critical. So now we're going to stop, take a measurement, and see where we're at. We should be at 87.1, give or take. And we are at 88 millimeters. Okay, so we got a little bit of material safety to play with. We're going to leave it right there at 88. I was planning on having it at 87 and a half, something like that, but we'll leave that right there where it's at. That's plenty of material there. So now we're going to go ahead and put our 50 millimeter step in and continue on. So we need to have, let's see, 38, and then we've got 87 that we need to have, and 38 needs to be the width of our final, or the outer diameter here. So let's go ahead and rough that out. So that means we're needing to take off about 45 millimeters. So we're going to go ahead and then run our tool back here, reset our travel dial to 0. Okay, travel dial set to 0, and now we can go ahead and now we've got a little bit of a line etched in here, so just for reference, and we're going to leave a little bit of material safety there as well, so that way when we finish up with our step, take our final measurement, and then go ahead and run it in. So I'll, let's see. Whoops. Got to put you in gear. Okay, we're touched off there. Take a 2 millimeter cut. Actually 1 millimeter on the dial. You don't want to. Well, here's our finished product. So let me go handheld here and bring you around and show you. Right. Here we go. And we've got our final dimension here at 38 millimeters. Left a little bit of material on there just for shits and grins, mainly because the The material now is hot, and so there's going to be an expansion factor there, although it's not going to be much in cast. It's also just a little bit of a additional idiot safety in case we need to take off a little more. Reach our final destination, our final dimension of 51 millimeters, chamfer this edge. And what we're going to do later on is not use the lathe to take this tip off here, but we're going to take it off on the mill. And we're going to use the boring head for that, and I'll show you guys how that'll work later on. But for now, we are ready now to take the Arbor completely out of the lathe and move over to the mill and get set up over there. So let me get the parting head, the dividing head up on there and all that good jazz, and trammed in, and do that off camera. So remember in, well, I guess in grade school, and then you probably had some in high school too, fractional, using fractions. This is where that part of math is actually going to come in useful. Other than that, I haven't had a use for it in real life other than this. So here we have a dividing head with a gear ratio of 40:1. So I perched the camera up a little higher so that you can see it better. And then, of course, my dividing plate and everything has been set up already for a 13 tooth. I did a little trial run on a smaller gear for this tripod the camera's sitting on, and it also had a 13 tooth gear. And so I actually had to set this up, and it's been like that ever since. So let me bring you in a little closer here. Okay, I'm going to get the sector arm out of the way here, loosen the brake so that you can see it better. Now this gear, 13 tooth gear, unfortunately I don't have a plate with 13 holes. I could make one. I think I'd go down to either 14 or 15. But you know, a 13 tooth gear, you'll need a plate with a multiple of 13s. So here we have a 39, which is a multiple of 3. So this is what the formula is going to look like. For that, you'll have 3 times 40 over 39, or 40 over 13, and then it converts to 120 over 39. So then we'll set our one sector arm to 0. So we'll need to do three cranks on the revolution, and then there's 3 39ths as well that are left over that we still need to make up for on that. And so then we have to go 3 more holes on the sector arm. We set our sector arm, and then, okay, we'll set the peg in here. Let me switch the camera angle so you can see that even better. So here we've got our sector arm pin, or our pin in the first hole. This is where you plug in your Arbor, or chuck it up, set that, and then as you crank it, you can this one here locks up out of the way. So let me do that again here. So now the pin's locked up out of the way. So then we give it 3 cranks, and make sure you don't introduce any backlash, and then you'll rotate that to where the pin comes out again, and then let it snap into that 3rd hole. So, and that's how you follow through, and then you just push your sector arms ahead, and then rinse and repeat. That's the process we'll be using to cut this gear with. Well, I've got the dividing head set up on the mill here. This is a piece of the stock that I use to make the Arbor with. This is a pre-ground shaft. It's fairly accurate, down to, I think plus or minus 0.05 of a millimeter. So I'm going to use this to tram in the head, and we want to make sure that because this dividing head can tilt up, we got to have it trammed on the level and trammed on the longitudinal, or what would you call it? Anyway, we got two different setups here to do on the tramming. One to get it parallel to the table, or to the longitude of this, and then two-dimensional. I don't know how to quite phrase it. Somebody help me out in the comment section below here. But anyway, let me zoom you into the dial indicator here and to show you that we're going to see first just how much we're out. Okay, we got a little bit of a bad glare here, but you can still kind of see the dial. So I'm going to bring this in until we hit 0 on the dial, and then we're going to traverse longitudinally. I raised the table up until we hit, you know, pretty well the apex of the rod here. So let me traverse all the way in here, see where we're at, and we're falling and falling and falling. So we're going to go ahead and run this all the way out here until we get close to the chuck. So here we are at the chuck. So now we're going to bring this back in to 0. And now we're going to give our rod a little tap up here. Or we can tap on the dividing head back here. So now we're at minus, let's go 1/10 here. And then bring it back out to 0. So now we're going to, okay, and so we're climbing again. We don't need to do much here. I'm just going to give it a little love tap up front here. Okay, we're still climbing. And a little more love tap. So now we're going to go back. Now this is the more critical part, because this way, this part, the depth of your tooth is going to be dependent on that. So we'll go to minus 1/10, bring it back out to 0, and run it back out and see where we're at. Okay, we're holding steady, and we're still falling just ever so slightly. A few hundreds. Let me see if we can't. And there we are. Oops, going the wrong way. So we're holding fairly steady at 18. You can see the wobble of the needle. That's probably some of the surface errors in the surface finish of the rod. So I'm going to tighten up this rear nut here and see. Now we're back to 19. And we're falling slightly. That's 1/100th of a millimeter. I'd say that's not too bad. So now let's check the horizontal. So now I'm going to drop the table and the wrench. So now we're going to take our little feely footy here and bring it out towards the front. Run the table out, find the apex of the center of the rod here, and now raise the table up, zoom back in, raise the table up until we hit 0 on the dial. So now we gotta do the same procedure for the level. Okay, we're falling slightly, or raising slightly. So we got 15 here, so we'll go back out and we'll raise this up, the head up, just ever so slightly with the jack. Oops. So now we got to take our head loose back here on the back side. Alrighty, got our head loosened up here, and so we're going to raise this up just slightly. We're going to take it up to about 1/10 here, or a little past. Okay. What I'm doing is I'm putting tension on it to push the head up just ever so slightly, and then going a little bit beyond it, and then releasing the pressure and letting it go. Let me grab a 30 millimeter wrench here. Okay, I'm going to ease the pressure off. Now we're at 1/10. So I'm going to take it up just a smidge beyond. So now we're at 0.2. And we may be just a little bit high, but let's see. Well, hallelujah, we're dead nuts. So we're just going to go ahead and leave this the way it is, tighten up the back bolts on the dividing head, and mount up our arbor. So now we're selecting the cutter. Now this is going to be kind of tricky. I have here a gear that's virtually identical in size to the one we're trying to make. This is one out of the drivetrain. Now it does show some wear, some significant wear as a matter of fact, when you get to looking at here. This gear might get remade as well, but I went and bought a set of these gear cutters. These are from a Ukrainian manufacturer out of the former Soviet days. This is a M5.5. This is the #1 cutter. These work in reverse as far as the size selection goes. Like the #8 is for the racks. This is for smaller gears for, I forget how many teeth and smaller. I'd have to look it up, but this is a 13 tooth gear, and so we're going to stick the gear in here. Let me see if we can get this to show up. Now you can see, looking at I'll try and bring this in here. Now you can really see the wear pattern on the surface of the teeth because the cutter doesn't quite fill the gap here. If I move it back and forth, of course, then it does. But now it could be that this machine is almost 100 years old, that they were using British cutters, but I somehow doubt it because this M series, this 5.5, gets in pretty close. Now, if you guys that are gearheads out there know more about this, by all means chime in on the comment section below and part with your knowledge there to kind of supplement the monologue here. But anyway, the damage to this gear is, of course, pretty obvious, and so this cutter, the #1, is going to be the one that we're going to select for this particular project. Now we're not going to take the full depth of cut. This is cast. This is HSS. So we're probably going to take it millimeter at a time, just to see how it wants to act, see if it behaves itself. So let me get this put up on an Arbor and we'll go from there. So now we got all this set up. The Arbor. One of the things I had to do was cut a keyway into the Arbor here before I could continue on. I had a slitting saw on this Arbor and it spun on the shaft and cinched up the screw down here to the point where it wouldn't release, so I had to actually put it in the vise and then cut a new keyway for it so that the bits won't spin on the shaft. So now we know our blank here is 84 millimeters in diameter and our cutter is 18. So now we're going to establish the top of the cutter, where we're going to run it up until, with this parallel, until we touch. And so you want to get behind something with a little bit of, it's got a little bit of a light background so you can see the light coming up to the work. Let me bring the camera around here so you can see what I'm talking about. So now you can see the light between the work and the parallel, and I'm going to be raising it up until I just barely touch. And right there I am. I'm going to raise it up a smidge more and see if I bump into it. And that's where I'm bumping into it. So now I'm not riding up on it just quite yet, but I can feel the resistance of the parallel as it swings over. And then I can feel it scraping a little bit underneath there. So now we're up even. So half of the 18 is of course 9 millimeters. So now we're going to raise this thing up until we hit our center. Okay, so now we got our dial set here to 0. So now we need to raise this up 33 millimeters to get, we're taking half of the diameter, which is 42 millimeters, and then subtracting half the diameter of the cutter. So that means 33 millimeters is what we have to raise this up in order to get this on center. Okay, this was kind of a pain in the butt to get it going right, but as it turns out, 42 minus 9, half the diameter of the cutter is 33 millimeters. Once I got that figured out on the crank here, turned out to be right on center. So now we're going to go ahead and bring it in and touch off and set 0 on the dial, and then go ahead and start cutting. Okay, it's touched off. I'm going to go ahead and set 0 on the dial and take a cut of 1 millimeter. I'm going to go ahead and use our feed. Okay, we're turning our cutter at 180 RPMs. Seems to be behaving itself pretty good. measure depth of the tooth here. This is kind of a primitive measurement, but for right now I guess this will work. Oops. So we have 19.7 millimeters depth there. I'm going to remeasure that. I had 20 earlier. Yeah, we're at 20. So let's measure the gear on the mill here. So we'll do the same thing, lay out parallel here, straight on there, and then measure the depth. And we have 19.4 in depth. So what I'm thinking, I'm going to give this a try, is to climb mill on that finish cut, that last few tenths of a millimeter. Our cutter's still fairly sharp. So I'm thinking run this back in here a little ways and then climb mill on this. The gear's pretty warm from working it, so let's back this up. See what kind of finish we get on climb milling this. If it doesn't work out, we can always go the other way. Let's see, will we be able to rotate? No. So we won't be able to rotate, so that idea's out. So we'll just go ahead and take another 0.5 millimeter cut. And color it good. So fire it up and rock and roll. Finish after. Well, YouTube, there's our gear all done up now. Now it's just time to pull it at least out of the chuck and then set it aside. Now we're going to drill out the old gear and get it ready to adapt this one into it. Like I said before, we're going to drill out the hole slightly oversized to accommodate this, to give the internal mating surface a fresh surface. I mean, we could just go with the old one, but trying to hit that right on the money is going to be kind of tricky anyway. So we'll just go ahead and hit it. And then we've also got a little bit of material left on here so that whatever final dimension we end up with our hole, I'm not going to go to the dimension of this because, quite frankly, you know, trying to hit it's going to be pretty tough, and it's going to be easier to turn this down than it will be to open up the hole to the proper diameter of this. So, as you saw here in the previous handheld footage, sorry about the wobbly and the poor sound quality, but the finish on these teeth turned out pretty nice. The last cut was about 0.4 of a millimeter, and running at, let's see, 19 millimeters per minute. Yeah. And doing the roughing out, we were running at 90 millimeters a minute, and there at the, you know, I started out at 1 millimeter depth, and I tried to see what I could get away with, and so I bumped it up to 2 millimeters and ran up the feet a little faster, and it handled it just fine. Granted, the machine made a lot of noise, but you know, that's just the nature of the beast. This is cast iron, so it's going to, you know, sound like the teeth are going to come off the back gear of the machine. So anyway, it just took it just fine, and got it knocked out. So now we're getting ready, and like I said, the last finish pass was you know, just that 0.4 at 19 millimeters a minute to give it a nice smooth finish. Turned out really well. So now onward to the next step. So here's our gear mounted up on the table now. Now we're going to got the center dial indicator, or what do you call this thing? Center finder mounted up. This is the diacator, actually, is what the name of the brand name of this thing is. And so now we're going to try and get this centered. Yeah, he's starting to calm down quite considerably. I'm going to raise the table up just a smidge. I got a little bit of a ding here in here somewhere. Maybe get this board to cool down a little bit more. There we go. Okay, now we're getting a little wilder. Bring it back the other way. Yeah, there we go. That's about as good as it's ever going to get. So we're going to call that center, lock our table all the way around. Now I got to drop the table and put in the boring head. So I've got our boring head in here. We're going to run this at 550 RPM, which is usually what I run this at on this tool. And we're going to be, I already got the quill feet engaged. Got the only thing is I have to crank it by hand. There's a Oh, a shear pin in here. One of these first fine days I'm going to have to tear that open all apart and try to get at it and fix that shear pin. But anyway, otherwise I'd just do it automatically. But got to stop in between each one to advance the boring head and bore it out. So let's see. We'll have, we only need 45 millimeters of travel, and so let's see, we can lower this down. Sorry about my fat head there. So we're at 30. We need 45, take it down to 75, and that ought to do it. We'll take it to about 76 or so. Set the depth stop here and keep from going too far. Maybe a guy could do something with the rest of that stub of that gear someday. Fix it or use it as a boat anchor or something. So here we go. Oh, good thing we didn't do that. Run it the right way. Here we've got our gear all bored out. I've been turning on this part right here because I've been sneaking up on it. The bore itself, let me pull this out here, is 50, at least according to the guessometer. You can see the finish in here. It's a little rough, but that's quite all right. I'm going to put a little Loctite in here so that it holds the gear, the new gear, quite well. And that way there's additional security there that keeps it in there. And here you can see the finish on this is actually quite well. The tool bit's starting to get a little dull, so it's getting a little rougher, but that's quite all right. We want a little bit of a rough finish so that we get some of the Loctite to go in between the gaps here and create a bond between the big gear and this gear so that it doesn't slip. Now we're going to go ahead and use the old holes here for the old grub screws again. I don't see any reason why not to, other than just, or, you know, just depends. I don't think I can get the drill bit to behave, so I'm going to probably have to end up drilling new holes. But anyway, this is a press fit now. We're down to 50.1, I believe, on the diameter, and this is exactly 50 millimeters according to my guessometer. And so now it'll start quite well, and now it's time to take it off the arbor and press it in and see how it behaves. But once I press it in, I won't be able to add any more Loctite or Wiener sliders, so I'm just going to go ahead and Loctite it now after I get it pulled off the arbor and go ahead and press it in. The one key that you don't want, the key thing that you don't want to do here is create so much pressure that you're going to put so much strain on this that you're going to crack it, because this gear too is cast as well, so it doesn't have any give to it, or, you know, neither does this one. So you can gall this pressing it in, or crack the outer gear, which in both cases wouldn't be very good. So there's no way to check for galling on this, unfortunately. Once it's in, it's in. It's such a tight fit right now that I'm just going to leave it the way it is. I don't want to really push my luck and try to force the issue, shall we say, as far as the fit goes. But it's looking really good. I'm really happy with the way it turned out. So anyway, let me pull this off the arbor and press it in. Notice I'm tapping it alternate, you know, on alternate sides here so that it doesn't go in there cattywampus. And I'm just giving gentle love taps so that the pressure doesn't build up. Now we know it's going to be a nice press fit, so we're just going to give it some nice gentle love taps with the old mallet here and seat gear. Take the Arbor, use it. And there's our gear seated. So now it's time to go back and shave off this. One of the interesting features of this boring head is the fact that when you put here's the, I don't know what you call it, the hold rod here. This is like the Wohlhaupter series type of boring heads that allows you to plane across a circular surface. So I'm just going to go ahead and drop down the tool here a little bit, and I've got the feet engaged here, and now I just turn it on. I hold the stick and pull the feet out automatically. That's all there is to it. Then to reset, what you do is you disengage the feed and just crank it back. So let me zoom you in here and show you the tool in operation. Well, YouTube, that's a wrap for this episode of This Old Planer and Gearing Up. As you can see, our gear turned out pretty nicely. Still got to make a plate to put in here. I did offset the grub screws, put them in on a different spot. The drill bit just wasn't going to behave on this. I had a feeling, and so I didn't have an 8.3 millimeter end mill to actually put in an accurate hole and then be able to tap a thread in there. So I just said, to hell with it, and put in 2 new grub screws, and then the next thing is going to go, a plate's going to go on here into this hole, and that way that protects the frame and the gear from each other. I don't know, it might be copper, it might be brass. I'm thinking I'm going to get a piece of sheet brass somewhere, and need 4 millimeter sheet brass, and then just stick that in there. Probably Loctite it in just to keep it in there and color it good. So anyway, there's that. We got one more gear to make. The small gear that, let me grab that real quick. This little gear right here, I'll do that off camera. It's the same process as was before. Same thing, 13 tooth gear. No different. So I won't bore you to death, but here's the old gear off of this one. As you can bring it in here closer, you can see we bored it out with boring head and then just removed it from the larger gear. So I hope that was entertaining for you all, and if there's any thoughts, suggestions, critiques, comments, by all means, put something in the comment section below, even if it is nothing else, just to say hi. Do love to hear from my subscribers, and find out if there's any improvements that I can make to the videos to help you out a little better and make it a little more pleasurable for yourselves. As you can tell, I'm just a novice when it comes to this kind of stuff, but we're trying here and putting together some decent material for folks out there so that folks can learn something, or see how other things are done. So anyway, with that, we'll see you guys again soon.